Welcome to Study Loop.
Let's use the substitution to rewrite this integral as an integral of a rational function. Here, many choices for you that may work here. Let's just try x to the 1/3 because of this x to the 1/3 in the denominator. Take a differential on each side. So here we're using the power rule for derivatives. And I can rewrite this as 1/3u squared. And the reason for that is because of this. Square both sides. So u squared and x to the 2/3 are the same. And then I could go ahead and multiply the 3u squared to the other side. And I can replace dx with this expression on the left. So let's go ahead and do that in our original problem. This now becomes integral. So we should also check the limits of integration. So to do that, we plug in the original bound 0 and 1 into x in the u substitution. And when you do, the u values that you get back are also 0 and 1 in that same order. So x equals 0 implies u equals 0. Then x equals 1 implies u equals 1. Then dx up top, that's just 3u squared du. Now in the denominator, we just have 1 plus u. Now, since the numerator has larger degree, let's go ahead and do polynomial division. 3u squared over u, that's 3u. Go ahead and multiply that out. We have minus 3u divided by u, minus 3. And then multiply that. And we get a remainder of 3. So this means that we can write our integral as the quotient, which was 3u minus 3. And then we have our remainder. And over u plus 1, the original divisor. Now for the first term, let's use the power rule for integrals. Same for the second. Here, this is natural log. Now let me make a comment about this plus 1. If this plus 1 caused you difficulty here, just go ahead and do a u sub. And coming back to our integral, we go to the endpoint 0 and 1. So plug in the 1 first. You have 3 over 2. Then you have minus 3 plus 3 ln 2. That's for plugging in 1. And then when you plug in 0, each of the 3 terms goes to 0, and the third term goes to 0 because natural log of 1 is 0. So we subtract off 0, and then we just have 3 natural log of 2. And then we have minus 3 halves. And there's our final answer.